Hey, it's W5HRO. Well, I'm messing around with this amp. I'm backfeeding. This is something I wanted to show everybody. See how I'm using this antenna? It's old MFJ antenna analyzer to backfeed into the 50 ohms here to just go through the pi network in the reverse direction. It's the same thing. I'm matching 50 ohms to the, if I calculate out my RFPA load ohms, it's 6.439K. So what was funny was I found like a 7.5K resistor, and I found some 200Ks, and I paralleled a bunch of them. I just twisted them together and I put the ohm meter on it, and I had to look down at the meter twice because I'm seeing 6.44K, and that last 4 was flickering between a 3 and a 4. So I moved the decimal point over on the meter, and I went, "You've got to be kidding me. How did it come out exact? I've never been that lucky before." But you see, I'm just going to where the tube would normally go, and I'm just replacing the tube with non-inductive resistors, of course, that equals my RFPA load ohms. And I was playing around seeing what would happen on 20 meters, and you know what's funny? The Q is extremely tight, and I actually got the thing to dip all the way down, and I got a 1-to-1 SWR at 50 ohms at the output of the amp, and I'm like, you got to be kidding me. So what? See how tight it is though? Here's the plate. It's really super tight, but it was greatly dependent on where the load was. Now I did get it to dip without doing anything yet to the coil. That's what's surprising. So now I'm going to try it on 17. I don't think that's going to cut it. Let me move the the inductor to the 15 meter position. This is the 15 meter strap here. What I was going to do was I was going to put some series caps in place of these straps to add the series caps there. That way when I switch it, I can switch to different cap values without having to use the other relays. Then I can use this one switch on the front panel with the matching knob, click, click, to turn the relay on and off for 160. That's going to throw the big doorknob in parallel with this cap. So that's what I was going to do. But it's funny, I can get this thing to dip on 14, but it's really tight. I had to backfeed it. What I'm going to do is I have these, I mentioned this before, I have these other knobs. I'm going to mount these plates right flush against the panel, and I'm going to put these knobs in place of these Bakelite ones. That way that pointer's going to turn. And I guess what I could do is I can backfeed it like this, and I can find out exactly what line I need to resonate this thing on 20, and then I can, I could probably get it to work on 20 right now on the dummy load and see how much power I'm getting out. Now that I figured out that I had to adjust the load way back first before I could see anything on the, I could see any kind of a dip. The problem is I know the dip the attenuation of that dip is not low enough at the input to that pi network. It's the attenuation, it should dip down further, so that's why I'm still going to play with it. I'm going to try to reduce the C. So let's see what happens. Let me put the meter here on, the analyzer. What is it? What's the top end? So 18168. So let's stick it like 1870. That's close. Yeah, that's close enough. 160 something. So let's see if I can get this thing to do anything. Let me adjust the loading first. You got to get a dip in the loading first, is what I've noticed, and then I don't think it's going to resonate on. Oh my God, it's coming down. I doubt it's going to be very efficient. Oh, look, it's working. You got to be kidding me. Well, right there, I'm dipping on 18 some odd megacycles. That's 17 meters. Look how that cap is just barely meshed at the corner. But I don't know. I don't think with this low power input going the reverse direction, I don't think that dip is. You know what I need? I need gear reduction on this thing. But that's okay. It would really help to have gear. If I had a gear reduction on that capacitor, it might work as is. Holy cow, but I don't think, I think when I get the high V on there in full power, I don't think that dip's going to be, it's not really going to dip enough where I may not even see it on the current meter when I do it, but I guess I could plug it up and try it and see what happens, right? But I'm surprised that, see, that's what's good. You know, people say these analyzers aren't good for anything if you're going to try to analyze vacuum tube circuits. Not when you're going the reverse direction of your tank circuit on your amplifiers. This works perfect. Because see, right now I've got that thing resonant. I got 50 ohms of the 6.4 some odd K. Perfect match. Oh my God. That's surprising. So, I guess what I should do is I should go ahead. Well, I was thinking too, you know, if worse came to worse, I could turn this capacitor upside down to get this one strap a lot shorter. I could do that too, you know. And the problem is it's going to drop this knob. Well, the reason I didn't want to do that because I'm going to have to make another hole down farther. And I think what might happen is it's going to shift it down so far that it may be too close to this one. It's going to drop it down. It's going to drop this down at least down to about here, I think. And I don't know. That's going to be... That knob cosmetically could have been dropped down a little more, and it probably would look better on this transmitter. I mean, I could drill the other hole, and I'm going to mount this round, you know, the graph on it anyway. The part of the knob that's going to stay there for the fixed numbers. So it's going to cover any hole, the hole that I'm not going to use anymore. So it would actually patch this hole. I could just put something in there too to make it flush. Some of that metal tape, kind of little square metal tape, stick it over the old hole, but this is going to be covering it anyway. So I'm still wondering if I may, before it's over, I may flip that cap upside down if I have to. If I need to get it to work on the higher bands to get more power out, because it's probably going to work like this on 17 meters the way I've got it tuned if I set the exciter on the same frequency, but I have a hunch the power output's going to be low because it's not going to be very efficient. This cap, there's too much C on this tuning cap, I'm sure. So anyway, but that's where I am on this. I'm making progress. So, but I want to show as a lesson, these analyzers are good for stuff like this. You just got to know that you got to calculate what your RFPA load ohms is. It's just your plate voltage divided by the current you're going to run through the tube, and you just select that value resistor, put enough of them together, just some carbon comp resistors, 0.5 watts are fine, you know, and just do that. It's just make sure they're non-inductive. Carbon or metal films, carbon work better. These are carbon. So anyway, that's how you do it. So I'm plugging away at this. This is W5HR and an O.